So now we're moving on to lesson 6.3, where we're continuing on with our construction of confidence intervals, but now we're constructing confidence intervals to estimate population proportions instead of population means. And proportions are always going to involve using the normal curve, the z distribution. And the basic format of a confidence interval for a proportion is we take our sample estimate or our sample statistic, which is our sample proportion, we could use a p-hat, plus and minus our margin of error, which is going to have a critical value again. We said proportions are always z, and a standard error, which is found by taking the sample proportion times 1 minus the sample proportion, which is typically called Q hat, and dividing that by the sample size, and then square rooting. Now what makes this using the normal curve valid is we really need to check to be sure that the expected number of successes, which is found by taking n times p hat, has to be 5, and that the expected number of failures, which is found by taking n times q hat, also has to be at least 5. So if those both are big enough, then we can confidently use the normal curve. Now, p hat is determined by taking the number in our sample that had the characteristic we are interested in. They typically use the variable x to represent that, and divide it by the total number of people sampled. So in our case here, the number in our surveyed males that were of that particular age group was 399. That's our x. Divided by the size of our sample obtained, which was 634. That's about equal to 0.629, and MyLabs Plus has a tendency to want you to round that sample proportion p hat to 3 digits after the decimal point. So now we're going to take that n, our sample size, which is 634 males, and we're going to multiply it by our p hat, which is the 0.629 value that we just got. Clearly, that's a number much greater than 5. It's a little more than 398, so that's satisfied. And then our expected number of failures would be n, 634, times 1 minus that p hat of 0.629, 0.371. Clearly, that is also a number that is much larger than 5. It's a little more than 235. So therefore, our expected number of successes and failures are definitely large enough, and therefore we can continue quite confidently with the construction of this interval. So now we're going to go ahead and calculate the interval. We're going to take our sample proportion, which is again our 0.629, plus and minus our critical value, which we learned how to find using the table of critical values for the normal curve in section 1. And so for 90% confidence, that's 1.645. And then that's multiplied by the standard or 0.371, all over our sample size of 634, and then square rooted. To find the lower boundary or lower limit of this interval, we're going to calculate from left to right, 0.629 minus 1.645 times the square root of 0.629 times 0.371 over 634. And we end up with a lower limit of this interval equal to about 0.597. To find the upper limit of the interval, we'll do the very same thing, except we'll do plus the margin of error. And we'll have an upper limit of about 0.661. So we can say that we're 90% confident that the true proportion of all males in the age range from 18 to 64 is somewhere between 0.597 and 0.661, or if we change those to percentages, somewhere between 59.7% and 66.1%. The only thing that would be different for our 95% level of confidence, I'm sorry, I realized I hadn't been hadn't been recording there at the end, so I'm not sure where I left off, but I was mentioning that the way we go about determining the lower limit of the confidence interval is by working from left to right with the minus, 0.629 minus 1.645 times the square root of 0.629 times 1 minus 0.629 all over 634. And then the upper limit of that interval is found by just using the plus in front of the margin of error or critical value. So we can say that we're 90% confident that the true proportion of all males in the population that are between the ages of 18 and 64 is somewhere between about 59.7% and 66.1%. The only thing that would be different for the 95% confidence level is that critical value. We have to go out a greater number of standard deviations in the normal curve in order to capture the middle 95%. And we learned how to do that back in section 6.1, but that number is 1.96 for 95%. And if you need to revisit those videos from lesson 6.1, I would encourage you to do so as to how we find those critical values.